So today we're going to be talking about solving systems of three linear equations. So you're going to see that we have three different variables, so x, y, and z, x, y, and z, and we're going to need to solve for each of those three different variables. Now to solve, the first thing you're going to want to do is number your equation. So this is 1, this is 2, and this is 3. And then you're just going to want to take any two equations and solve for one variable. So let's take 1 and 3. So let's do 3x plus 2y minus z is equal to 6. And then x plus y plus z is equal to 4. Now, from what you can see, is both of the z's have the same coefficient. And that coefficient is 1. So that means it's going to be pretty easy to eliminate the z's and get an equation just in terms of x and y. So to eliminate the z's, we're basically going to add. So if we add this z term, so negative 1z plus 1z will become 0, which is what we want. So if we add down, so 3x plus x is 4x, 2y plus y is 3y. As I said before, negative 1z plus 1z is 0, so you don't need to include that. And on the right-hand side, you get 6 plus 4, which is equal to 10. So now you have one equation. Now we're going to do the same thing, except instead of taking equation 1 and 3, we're going to take two different ones. So let's do 1 and 2. So let's take equations 1 and 2, and let's write them down. So 3x plus 2y minus z is equal to 6, and negative 2x plus 2y plus z is equal to 3. Now when you're doing systems of linear equations, when you take two equations, so here you have equation 1 and equation 3, the variable you're eliminating is the z. So when you take your next set of equations, so two different equations, you're going to want to eliminate the same variable. Now it's easy in this case because the coefficient of both is 1, meaning that it'll be pretty easy to eliminate it by just adding. But in most cases, you're going to need to multiply by a different number, which we'll show you in the next example. But for now, let's just continue solving this. So if you go down, it'll be x plus 4y, which is equal to 9. Now remember, we are just adding in this equation. So we're doing 3x plus negative 2x, 2y plus 2y, and negative z plus z, which is just 0. And then 6 plus 3. So this is our second equation, and this is the first equation we got. So we're going to want to put this equation and this equation together and solve. So let's solve the two equations. So we have 4x plus 3y is equal to 10, and then x plus 4y is equal to 9. Now, as you can tell, this is just a simple system of equations. In this case, both of our variables do not have the same coefficient, so we're going to need to multiply. So we're going to call this equation 4, and we're going to call this number 5. Now to get from number 5 to number 4, as you can see, the x term here just has a 1. So the x term here only has a 1, but in this case it has a 4. To get from 1 to 4, you just have to multiply. So let's multiply equation 5 by 4. So let's do 4x plus 16y, which is equal to 36. So basically what we did now is take this bottom equation, so x plus 4y equals 9, and multiplied it by 4 to get 4x plus 16y, which is equal to 36. Now why did we do this? Because the fourth equation, so this equation over here, has 4x plus 3y. So if we bring that down here, we have 4x plus 3y equals 10, and as you can see, the coefficient of the x terms are the same. So in this case, we have 4x and 4x. Now what we can do is subtract both equations, because in that case, we would have 4x minus 4x, and that eliminates the x, which is what we want. So let's subtract. We would get 0x, and then 16y minus 3y is 13y, and 36 minus 10 is 26, and if you divide both sides by 13, you get y is equal to 2. So using y is equal to 2, we're going to substitute this y equals to 2 into this equation up here, so equation number 4, so that we can figure out the value of x. So equation number 4 So equation number 4 is 4x plus 3y, which is equal to 10. We know y is equal to 2, so we're going to do 4x plus 3, and in the place of the y, we're going to substitute 2 and equal it to 10. So 4x plus 6 is equal to 10. Subtract 6 from both sides, you get 4x equals 4, making x equal to 1. So now we figured out that x equals 1 and that y equals 2. So we still need to figure out z. To figure out z, we can basically substitute the values of x equals 1 and y equals 2 back into our first equation. So up here we have our original equations. Now we know that, let's bring it up here. So we know that x is equal to 1 and y is equal to 2. So let's take our first equation, this one over here. Let's write 3x plus 2y minus z is equal to 6. Let's substitute x as 1 and y as 2. So 3 times 1 plus 2 times 2 minus z is equal to 6. 3 plus 4 minus z is equal to 6. Negative z is equal to 6 minus 7. So then negative z equals negative 1, therefore making z equals 1. So we figured out that x equals 1, y equals 2, and z equals 1. So we've basically figured out the equation. We figured out the answer. So for these three equations, the solution would be x equals 1, y equals 2, and z equals 1. So here's our next example. In this example, you can see that one of the equations doesn't have a z term. It may look confusing at first, but it makes our work much easier. So we have three equations, 1, 2, and 3. So we know that we have to use any two equations at a time to solve it to two variables and then solve that using like normal systems of equations methods like the previous example. Now in this case, they've already given us an equation, so equation number 2, where we only have two variables. So now we're going to use equation number 1 and equation number 3 and then solve that to two variables and then use equation number 2 and solve it. It sounds confusing at first, but it's pretty easy. So let's do equation number 1 and equation number 3. Let's write them down. So 2x minus 4y plus 5z equals negative 33. And then negative 2x plus 2y minus 3z equals 19. Now, what you can tell is that in this equation, so in equation number 2, all the way up here, they have eliminated the the z variable. So there's no z over here. We have an x and we have a y, but we do not have a z. So that means that when we're solving the next two sets of equations, we're going to want to eliminate the z variable. Now in this case, the z in here has a 5 and here has a 3. So we're going to find the lowest common factor or multiple of 3 and 5. So multiples of 3 would be 3, 6, 9, 12, and 15. And 5 would be 5, 10, 15, 20. Now you can see that the lowest common multiple is 15, so let's use 15. So to get from 5 to 15, we have to multiply by 3. To get from 3 to 15, we need to multiply by 5. So this is equation 1 and this is equation 3. What we're going to do now is take equation 1 and multiply it by 3, and then take equation 3 and multiply that by 5. And you'll see why we're doing that just soon. So let's start doing that. So equation 1 is 2x minus 4y plus 5z equals negative 33. And then equation number 3 is negative 2x plus 2y minus 3z equals 19. So we're going to multiply the first equation by 3 and the second one by 5. And let's write that again down here. So it will be 6x minus 12y plus 15z, which is equal to negative 99. And then negative 10x plus 10y minus 15z, which is equal to 19 times 5, which is 95. So as you can see here, we now have two equations. We have transformed equation number 1 and 3 and made the coefficient of the z the same. So they're both 15. So now you can see we have a positive 15 here and a negative 15 here. To go from positive 15z minus 15z, that equals 0. So you can see that even if we just add these two terms, we'll get 0. That's what we need. We need to eliminate the z variable. So let's just add these two equations. So we're going to add down. So 6x plus negative 10x is negative 4x. And then negative 12y plus 10y is negative 2y. And as you can see, our z terms cancel. And then we have to do negative 99 plus 95, and that equals negative 4. So now we've come up with an equation down here that only has an x term and a y term. Now if we go back to our original question, sorry about that. Okay, if we go back to our original question, you can see that equation number 2 here only has two variables. So we can use the equation we just found and equation number 2 to solve for x and y. So let's take equation number 2 and write it over here. So equation number 2 is 4x minus y, which equals negative 5. Now the equation we found down here is negative 4x minus 2y, which is equal to negative 4. So negative 4x minus 2y, which is equal to negative 4. And let's just solve this like any other system of linear equations. As you can see, both x terms have the same coefficient. Since you want 4x minus 4x, which is equal to 0, if you add, you'll get 4x plus negative 4x, which is 0, negative y plus negative 2y, which is negative 3y, and negative 5 plus negative 4, which is equal to negative 9, making y equal to 3. So we figured out that y equals 3. Now if we substitute y equals 3 back into this equation or back into this equation, we can figure out the value of x. So let's take this equation and let's substitute y. So let's substitute y is equal to 3 into the equation. So we have 4x minus 3, which is equal to negative 5. All I'm doing here is replacing this y term with 3. So then we have 4x is equal to negative 2 and x is equal to negative 1/2. So now from all of this, we figured out that x is equal to negative 1/2 and that y is equal to 3. So as we did in our last example, we're going to want to substitute these two answers into one of our original equations all the way back here at the beginning of the question, and we're going to want to solve. So let's go up here, and we know that x is equal to negative 1/2 and that y is equal to 3. So let's take any one of these three equations. Now you don't want to use equation number 2 because there's no z term, and that's what we want to figure out. So let's use equation number 1. So let's rewrite equation number 1 up here. So 2x minus 4y plus 5z, which is negative 33, and let's substitute. So 2 times negative 1/2 minus 4 times 3. So I'm substituting x as negative 1/2 and y as 3, and leaving 5z the same so we can solve for z. So we'll get negative 1 minus 12 plus 5z, which is equal to negative 33. So we'll get we'll get negative 13 plus 5z, which is equal to negative 33. So if you add 13 to both sides, you'll get negative 20. So then divide both sides by 5, and you'll get z is equal to negative 4. So now we figured out the value of z, so that's it. So for this system of equations, the answer or solutions are x is equal to negative 1/2, y is equal to 3, and z is equal to negative 4. And that's it.